Hey guys, this is lesson 3.2, still slopes of lines and rate of change. Again, this is a very important standard, so I want to make sure as we move forward that you guys get to see some examples and understand this to the best of your ability. So let's look at just the definition of slope. So the definition of slope for any 2 points on the graph of a line, the slope m of the line can be calculated using the formula. So there's two formulas. Slope is rise over run. And you can see here, rise is the difference in your y's, and run is the difference in your x values. And that is also using 2 points, y2 minus y1, again, your difference in your y's, over x2 minus x1. So let's look at a couple examples using this formula. Alright, so this says determine the slope of the line. Alright, so we are given -6, -2, and 6, -6. So all I'm doing is pulling points right off the graph, and that's going to be my x and y from my first point and my x and y from my second point. So my slope is going to be y2, so -6 minus -2 over x2 minus x1. And again, when it has negative in the equation, y equals y2 minus y1 over x2 minus x1. So it has a negative in the equation. So when you're subtracting a negative number, like right here, that becomes positive, remember. So m equals -6 plus 2 and 6 plus 6. So m equals -6 plus 2 is -4 over 12. And -4 over 12 can be reduced. 4 goes into 4 one time, and 4 goes into 12 3 times. So that's equivalent to -1/3. So for number 9, the slope is 1/3. Let's change colors here so it's a little less confusing. Alright, so we've got another point, 4, 3, and 0, -5. And it doesn't matter which point you pull down first, as long as you label your x and y 1 and your x and y 2. As long as this x and y are from the same point, it doesn't matter if this is point 1 or point 2. What does matter is that this x and y are associated together. So that's why we label them point 1 and point 2. Alright, so looking at the slope formula, -5 minus 3 and 0 minus 4. -5 minus 3 is -8 over -4. You divide two negatives, it becomes positive. 8 divided by 4 is 2. So the slope for the second one is 2. Alright. For the last one, we have -2 and 3. And we have 1 and -3. Again, this is x and y1. This is my x and y from my second point. And I'm going to plug my numbers into my formula. So I've got y2 minus y1. y2 minus y1. x2 minus x1. And then I just simplify. So I've got -3 minus 3 is -6. 1 minus a -2 makes that +2. 1 plus 2 is 3. -6 divided by 3 is -2. So using 2 points pulled from a graph, you can use the slope formula to find those slopes. If you need to pause this and take notes, please do so. We're going to continue on to the next examples. Alright, number 12 and 13 say calculate the slope of a line determined by the ordered pair in the table. Okay, so just like before, we can choose any 2 points in the table. It doesn't matter. So if we want to choose 2 and 9, 3 and 7, we can do that. If we want to choose the first and the last point, we can do that. It doesn't matter which points we choose. So let's start with this one. Since we chose 2, 9, and 3, 7, we can call this our x1, y1, x2, y2, m equals y2 minus y1, y2 minus y1 over x2 minus x1. So we're using the exact same formula. The only difference is we pulled the ordered pairs from a table this time instead of a graph. So 7 minus 9 is negative 2. 3 minus 2 is 1. So negative 2 divided by 1 reduces to negative 2. All right, if we look at these two ordered pairs, we've got negative 4 and 5, and we pick 2 and 14. And again, it doesn't matter which ordered pairs you pick from the table. It just says calculate the line determined by the ordered pairs. So it doesn't matter. All you need is 2's for the formula, and they just give you extra ones. You can choose any 2. All right, so m equals 14 minus 5, 2 minus negative 4. M equals 14 minus 5 is 9, 2 plus 4 is 6. 9 and 6 are both divisible by 3. 3 goes into 9 3 times, 3 goes into 6 2 times. So my slope is 3/2 for this one. Again, if you need to take notes, please pause the video and go ahead and do so. All right, the next two are determine the slope given 2 points. All right, so this one is even easier because we are already set up with our x and y from our first point. And this is our x and y from our second point. So we're just going to say m equals 2 minus 3 over 4 minus 0, and simplify. 2 minus 3 is negative 1, 4 minus 0 is 4, so my slope for the first one is negative 1/4. For this one, same thing. I've got 4 minus 0, I've got 5 minus 0. 0 really doesn't change anything, so 4 minus 0 is 4 over 5. My slope is 4/5 for this one. All right, now we're going to look at finding the slope given a point and a slope. No, let me read that again. Use the slope of the given point to determine a second point. Okay, so we want to determine a second point on the line. All right, so slope equals rise over run, or change in y's over, sorry, this is hard to read, not used to writing on my computer, change in x's. All right, so to find the second point for number 18, our slope is rise over run. Our slope is 4, but if we put anything over 1, that's still going to be the same thing. And we're starting with our point 1, 3. All right, so since this is our change in y's here on top and our change in x's are on the bottom, to find our new point, we're going to do our x. Our x is here and our y is here. We're going to do our x plus our change in x's, so 1 plus 1, or 2. And we're going to take our y value and do plus 4 is our change in y. So 3 plus 4 is 7. So our new point is 2, 7. So we found a second point on the line given a point and a slope. All right, so let's do the same thing with this one here. So we're given a slope of 3/2 and a point of 0, 0. So we're going to have, this is my x and this is my y. So that's my first point. So I'm going to take my x and my change in x. Okay, change in x's are on the bottom. Change in x is +2. And I take my y value, which is also 0. And my change in y is 3. So 2, 3 is another point on this line. So you can use your slope and a point to find a second point on the equation. All right, for each situation, first determine the rate of change for each part of the graph. Then find the average rate of change over the entire time period. Okay, so when it says find the rate of change for each part, that's because from here to here, you can see it's one steepness, and then from here to here is another steepness. So what they want us to do is to break it up and find the first rate of change for each part. So we have to do this part first. So we're going to go from 0, 0 to 4 and 1,000. And then we're going to go from 4 and 1,000. And we're going to go from 10 minutes to 1,400. All right, you should pause the video and see if you can find the average rate of change for each part of this graph using the same formula we've been using throughout this. When you finish, come back and we'll work it together. All right, let's look at this. We're going to have 1,000 minus 0. We're going to have 4 minus 0. And if we reduce that, I believe 1,000 divided by 4 is 250. So the slope will be 250. All right, and that's for this first part here because we used 0.00 and for 1,000. So that's for, let's call this the first part. So we'll say this is for slope of the number 1. All right, so we'll do slope of number 2. So let's do slope 2. And we're going to do change in y's. Is that 10,000, 800, 1,000? All right, so that should be 1,400. Sorry, that's 1,400. Make sure my numbers are correct here. 1,200, 1,400. So I had an extra 0. All right, and then 10 minus 4. So the slope of the second part of the line, 1,400 minus 1,000 is 400 divided by 6. 400 divided by 6 is 66.6. Can we write that as a fraction? We can reduce that to 200 over 2. It's going to be 200 over, oh, sorry, 3. Read my calculator wrong. All right, so 200 over 3. So it's rise over run. All right, now it says to calculate the average rate of change. You always have to read the whole question. So it says find the average rate of change over the entire time period. So I'm going to leave this for you guys to do on your own. 0, 0, and 10, and 1,400 will give you the average rate of change for the whole thing. So you can do that on your own, okay? All right, the last thing I want to go over, Make sure you review slope between two lines and slope of a rate of change. These are important and they